Hi everyone, my name is Martin and I have here some data from a few test cases of the GetFreeDestination function in Space Engineers. And basically what you see here is I have beamed a target several times, and this is a target with the size of 12 meters in diameter, this is 30 meters in diameter, this is 100 meters in diameter, and these three on the top here are from 1 kilometer away, and this is from 25 kilometers away. And from this viewpoint I have in this circle here, this is where I beam the target. The target is located here, and I beam here, and then here, and then here, and then here, and so on. And these blue one are actually I hit the target with the GetFreeDestination function, and the returned positions in 3D space are these one, and up to this point where I actually miss the targets, and you get the point back. So you can see the target is I hit out to 5.4 meters away. The radius of the real target was actually 6 meters, so it's somewhat correct. But as you can see, there's some kind of safety distance. The radius of the beam width I use for the GetFreeDestination function is actually 0.5 meters, so it's very small. And anyway, you get the return value, return position that is quite far away, so there's some kind of safety distance here. Anyway, as you can see, what you get returned kind of resembles like a circle in a plane, right? When you keep doing in this direction, you kind of get a circle in this plane, and that's actually what I've used as a method to determine the center point or the location of the target. I'll show you that, and this is for the 30 meter target. As you see, it's essentially the same, but you see there's a little less distance here, safety distance. And this is for the 100 meter diameter target. And you can check at 25 kilometers, what you get is more or less exactly the same, so it doesn't matter how far away you actually beam the target from. So let's have a look on how this actually works. So if you imagine this is our location, the green star here, and this is where we're beaming the first beam direction and the length of the beam, and we get something back that's located here. We hit something actually, and if I zoom in really a lot, you should see that it's not exactly on the line, it's a little bit shifted to the line. So what I do, I take that and I project a point on the line at the same distance as the red GetFreeDestination return value, using this direction, or actually using this position return value and this position here and our own location. I project a plane. I calculate a plane and in 3D space, and I use this is the plane normal here, and I also determine an X direction in the plane, this one here, and a Y direction in the plane. And I have some methods for transforming a 3D space point, or projecting a 3D point in space to the plane XY coordinates and back. So what I do, I beam through 2 more times, in this case here and here, and what I do then is you can't really see that, but the circle, red circle, are the return values from the GetFreeDestination function, and the crosses inside the circle are what gets beamed on or projected to the plane. But since the circles are essentially already in a plane, it's more or less the same location. I use this 3 points in the plane. I define a circle by these 3 points, and then I calculate a radius and a center point of the circle, and the center point of the circle I then transform from the plane coordinates to the 3D coordinates, and the center of this circle is actually where I say the target is. So that's how the method works essentially. It uses 3 GetFreeDestination functions. Obviously, when you have this kind of radius from the circle, you can get better approximations of where the target is or where you should beam. So if I beam right here on this side of the target and I know how large this circle is, I can take a larger step and end up on this side, and what I get returned is a position on this side of the circle instead, and that way you get a bit more accurate estimation of the circle radius and circle center point here, so you get a bit more accurate position of the target. So I'm in the game now, and I have built a ship and a script for this. Let's see here. Oops. Alright. Let me just make sure I have the latest version. Right there. Okay, so I actually made a missile class as well, and I use block linking to determine to talk to the missile and guide them to the target. And I have 3 types of missiles here. These are really not that effective, but it's just a proof of concept. So this one has only 1 thruster in one direction. This one has thrusters in all 4 directions except forward and backward, of course. And this one has 1 thruster in the side. So this one has to rotate that thruster to correct its direction, and this one just has to point the targets, and the inertial dampeners will take care of the rest. This one has to drift a lot and fly sideways and that to get to the target, basically. So let's see, I can add these 3 missiles with my script. Let's see if I can lock these targets here. These 2 on the right is actually a bit too small. I haven't made a method for locking targets at this range really, so I'm just gonna cheat a bit and tell my target, tell my program where to beam the beam to hit the target the first time. Alright, so as you can see here, this one is the larger target. This is the radius calculated from a circle I showed you in MATLAB, and this one is the 30-meter target, 30-meter diameter. This is the radius that gets calculated from the script, and this one is this very small target that you can barely see from out here. It has a radius of about 6 meters, but the calculated radius, because of this safety distance that I showed, is actually around 20 meters. This is the target location, and this is the velocity. This one is actually located at this exact coordinate. I checked how accurate this method is, and it's very accurate. I get readings. I get an error about 1 centimeter. So this is accurate to about 1 centimeter in determining the actual location of the target. And this is the velocity. I use a Kalman filter for determining the velocity and predicting the target location for moving targets. And I have a state transition model that I might show you guys later. But anyway, it works really well, and I want to show you this. So I can select all these 3 targets here, and I can fire 1 missile, fire another missile, and fire a 3rd missile, each on 1 target. And here's the thing I also have built into the script. Each target only gets beamed from one of these RC blocks, and if it gets obstructed, like this one just got obstructed by the missile because the missile flew in between the target and this block, it will actually try beaming from another RC block. In this case, it's beaming from one of the missile, and it sees that, oh, now I get the target, and it works. so it keeps that one instead. And we do 3 GetFreeDestination calls for each target, and the missile, each and every missile that I fire can get the location information and target velocity information and everything from each of these targets from that. This right here is the time of flight estimate. I do some estimation of a collision point between the missile and the target. So if the target is moving, I will actually head towards a point in space that I believe the missile and the target will collide, and not just head straight for the target. And yeah, let's fast forward until it hits, because it's gonna take a while waiting for these missiles. Alright, so the missiles are about to hit, as you can see from the time of flight there, and I will zoom in and see if I can see something. As you can see, that's the small target, it's very hard to see. Oh, it hit the large. Oh, it hit the small, and that hit the middle one. So we hit all the 3 targets, and you can see you can no longer see the missiles. This actually got a speed, you can see. I actually bumped into this one, so you can see the target is actually moving. And you can see the prediction of the speed here as well. Yeah, I'll show you a moving target as well. Alright, so we're in another map here, and let's add the missiles. And let's lock this target, stationary, from 15 kilometers away, and then we have a moving target here. Let's lock this one as well. Alright, so here you can see the speed is being calculated from in the comma filter, and the distance, and it's really stable and really exact. If you look at these velocity values, there's no jittering because of the comma filtering being done, as well as the target location, of course. And yeah, let's just fire the missiles and see how we do. Let's fire 1 missile on the stationary and 2 missiles on the moving targets. See, this one heads off in that direction towards this one. I didn't actually see the other. Anyway, and as you can see, because this got obstructed by the missile, it switched to another RC block to use, which is located on the missile. And I also want to say that if you get obstructed, if the target ends up behind an asteroid or something, my script will actually recognize that it is obstructed, and then it will continue predicting the target's movement with its last known velocity. And if it comes out on the other side of the asteroid, you can actually pick up the target again, and it recognizes the target by seeing that it has the same radius as before. And yeah, let's zoom in and look how this looks. You can kinda see a small missile right there. Okay, so we're about to hit that one. And there you go, we hit it. And let's see. We are about 30 seconds away from hitting this target, and I think you can see the missiles. You can actually see the missiles right here. And you see they're heading towards a point somewhere around here, I guess, or something, which is a collision point that I calculated between the red ship here and the missile. So they're not heading straight for it's actually heading for a collision point, and we should see 2 hits here soon. Yeah, and it's about to hit. And we get the first hit, and I get the second hit. So yeah, that's my method of calculating the target position with the GetFreeDestination function. And this script I will release soon. It's not really done yet, I have some work still to do on it, but it works really well, as you can see. And I'll also make a small ship with the kind of demo that's a little better than this, so you can play around with the script. But I still have some work to do on the script before I release it. In the meantime, if you want to use my method for determining the target location, go ahead and do that. It works really well. It takes 3 GetFreeDestination function calls for each target. It's one more than you perhaps may need, but you get a very good estimate of the target location, as you have seen in this video. Alright, see you later.